Don Yeomans has analyzed the Shoemaker-Levy 9 event.
The Shoemaker-Levy 9 impacts was an eye-opener for the public and the scientific community in the sense that these cosmic collisions do happen from time to time, and the energy that they can generate are just enormous. It's a good thing this thing hit Jupiter and not the Earth, because it would have been a serious problem on Earth.
Had the Shoemaker-Levy 9 struck Earth, it would have made devastating impact craters, the largest about 40 miles wide. Any one of them could have destroyed a metropolitan city and churned up enough dust to block sunlight for months.
Jupiter, being in the outer solar system and being far more massive than any of the other planets combined, takes a lot of hits that might have otherwise been destined for Earth. So Big Brother Jupiter is out there watching us.
Jupiter acts like a planetary goalkeeper, but will it be able to deflect 2003 EL61 if it breaks loose from the Kuiper Belt and tumbles toward Earth?
It's also possible that it can hit Jupiter like Shoemaker-Levy 9 did. This object is about 2,000 times bigger than the thing that hit Jupiter, than Shoemaker-Levy 9. So it would be an incredible explosion. In the night sky, it would be the single most prominent thing that you could see. It would be bigger than the full moon, at least the tail of it.
Because collisional families are difficult to locate, researchers are eager to study 2003 EL61 and its relatives.
Less is known about collisional families in the Kuiper Belt, simply because fewer Kuiper Belt members are known than we know about asteroids. So less research has been done to try to find collisional families within the Kuiper Belt.
As of today, we know of only this one collisional family in the Kuiper Belt. They're very hard to find and to recognize, and we got extremely lucky with 2003 EL61 and its family. And we're working right now trying to figure out other ways that we might be able to find these additional families, because they must be there, but we just don't know how to find them yet.
Like these clay pigeon pieces, family members in the 2003 EL61 family all remain in similar orbits today. We're able to follow them today and to learn more about the history of the Kuiper Belt and of collisions.
One enduring mystery is when the 2003 EL61 collision actually occurred.
We think we can look at where the different objects are now and try to essentially run time backwards and figure out when they were in this one big collision. Our best guess is that that answer is going to be essentially at the very beginning of the solar system.
2003 EL61 and its family were probably created during one of the most turbulent periods in the history of our solar system, when collisions were as common as stars in the night sky. From the beginning, collisions have been a fact of life in space. They created much of our universe, and at the same time, destroyed some of it along the way.
Collisions are the way that you build planets. Without collisions, you don't have planets to begin with. You start out with very small particles. Each one of them collides together, bigger and bigger and bigger and bigger, until you slowly build up these planets. At the same time, collisions can destroy planets.
The planets in our solar system were created during a period called the Heavy Bombardment that happened over 4.5 billion years ago. And the collisions didn't stop with the Heavy Bombardment. Over 600 million years later, our solar system experienced another spike in collisions during a period called the Late Heavy Bombardment. Stray rocks, too small to become planets, played interplanetary billiards, striking and bouncing off other bodies with tremendous force.
There were chunks of things flying everywhere, and so there were many, many, many collisions. A lot of the craters that you see on the moon were from that very early period, right when the solar system was still forming.
And our moon reveals just how volatile the period was on Earth.
We can even calculate to some degree, based on cratering on the moon, just how often we got hit by these rather large objects, say 6 miles across.
Towards the end of the late heavy bombardment, we do get asteroids hundreds of miles in diameter coming in and striking the planet. Those are certainly capable of vaporizing the oceans and leaving a tremendous scar where they hit, raising the surface environment far beyond the possibility of any life surviving.
When the late heavy bombardment subsided, approximately 3.8 billion years ago, objects that didn't coagulate into planets sought refuge in cosmic graveyards. In the outer solar system, leftover rocks reside in the Kuiper Belt. In the inner solar system, they collectively orbit in the asteroid belt. Like in the Kuiper Belt, collisional families have also been discovered in the asteroid belt. They're pieces of asteroids that originated from a larger object that was broken apart by a collision with another asteroid.
Collisional families in the asteroid belt result when one asteroid gets hit by another and breaks into pieces. The fragments actually stick together in their orbit around the sun, and astronomers can identify collisional families by looking at their distance from the sun is the same, the tilt of their orbit is the same, and the ellipticity, how squashy the orbit is similar. Also, if we see that the asteroids are made out of the same material, it's a good bet that they may have originated from the same object.
There are approximately 20 to 30 known collisional families in the asteroid belt. Scientists are keenly interested in one galactic collision that produced the Baptistina family, wayward fragments that originated as one single body, the size of Mount Everest. About 160 million years ago, this colossal rock was broadsided by another giant rock in the asteroid belt. The deep impact created a shower of smaller pieces, over 136,000 of them. Scientists estimate that 20% of the rocks escaped the asteroid belt, and 2% of them rained down on Earth. Some say there's a 90% probability that one of the Baptistina asteroids was responsible for the extinction of the dinosaur. 65 million years ago, a myriad of dinosaur species ruled the prehistoric world. But a catastrophic event wiped them off the face of the Earth. Now, scientists have good evidence of what happened to them. It's now been confirmed that a gargantuan cosmic object plummeted down from the sky and exploded in the Yucatan Peninsula near the modern-day Mexican village of Chicxulub.
We think it was an object at about 6 miles in diameter, coming in at about 12 miles per second, which would cause an impact energy of about 65 million megatons of TNT. Now, to put that in perspective, that's about one Hiroshima-type blast every second for about 140 years.